I'm John, and this is my video on .NET application architectures. So in this video I'm going to be giving a quick run through of some of the typical architectures we might use for a .NET application and just comparing them and how they relate to some software development principles such as dependency inversion principle and domain-driven design. So we're going to be looking at three separate architectures: the all-in-one architecture, the N-tier architecture, and then the clean architecture. And then we're going to be comparing N-tier and clear architectures as two separate options and the advantages and disadvantages and the characteristics of each. So first of all, let's look at some key concepts. So I just wanted to run through these quickly as they are key concepts that are agnostic to the programming language or framework we're using in software development, and they can sway your decision around which architecture to go for. So first we've got dependency inversion principle, and this is one of the 5 solid principles, and it says that high-level modules should not depend on low-level modules. And it says you should depend on abstractions and not concrete implementations. So in this context, high-level module is anything, a class or component that is calling something else. A low-level module is anything that does not depend on anything. So both high-level and low-level modules depend on abstractions, of which should not depend on implementations. So this is dependency inversion principle. And it will come up later as we look at some of the other architectures. We then have domain-driven design, and this emphasises the importance of building software that closely aligns with the underlying business domain. So it puts the domain at the centre of the design of the application and enables us to focus on what is the business problem we're trying to resolve. It also helps ensure ubiquitous language between developers and domain experts. So this can encourage good communication between all the different stakeholders and technical people, reducing the barriers and encouraging feedback loops. And it's aimed ultimately at creating clarity and a shared understanding when developing complex software systems. So now let's dive into some of the architectures. So the first one we've got is an all-in-one architecture, and this is the simplest. It's the default, and it's the easiest to set up and build and deploy. So you can see here we've got a single project. This is a screenshot from Visual Studio. So to get this, we may have gone through the built-in Visual Studio wizard when it first opens up and it asks you to create a project, and you create one. You create a solution, which is here in this example monolith sample. We've got in here a web application, and then we have a folder structure. So a folder structure in an all-in-one application is the primary way that we provide or meet the separation of concerns. So we've got a folder for data, one for models, services, views, which is the presentation layer. So folders provide our separation of concerns in an all-in-one project. So one project for the entire application architecture. Simple for smaller projects, but with less overhead deployable. So ultimately, due to its simple nature of just having a single project to deal with, it can be deployed as a single unit, and it's very straightforward. We don't need to worry about the deployment mechanisms or deployment process for separate projects. It's a simple, straightforward deployment. The downside with this architecture is it can become complex and it can lead to spaghetti code. So very quickly, as we start adding complexity to the application, we're going to end up with more and more classes being in the same project. They could end up being more tightly coupled. and this can lead to issues with maintainability in the long run. Advantages: rapidly deployable due to the lack of complexity, as I mentioned, less overhead, no need to manage multiple projects and dependencies. So as we get into more of the other architectures, we're going to have multiple projects instead of just the one. We're going to have dependencies between those projects that we're going to need to manage. Of course, with an all-in-one application, we don't need to worry about this. Simplified deployment, direct data access, no complex data access layers. But then we have the disadvantages: scalability. Performance can become an issue with scale. So we've got that one project, all of the logic and components within that project share the same compute if we deploy it into a single machine, which we would because it's an all-in-one application. So this can cause difficulty with scale, especially as the application becomes more complex. Maintenance, so with the nature of that and just having those separate folders, that's the only thing we've got, a separation of concerns. It can become difficult to navigate and refactor. And then coupling, as I mentioned, components, classes, and stuff like that can start to become tightly coupled. So then this leads us on to the next architecture, which is an N-tier application architecture. So the all-in-one architecture that we were looking at in the previous slides, a very traditional approach. It's done as well in the past, and it's the default option. New developers or very small projects might use this architecture. N-tier application architecture is also another quite traditional architecture, but it's been commonly used over the last decade and more. This is an architecture commonly used for production applications, and it splits our application down into 3 layers: presentation, business logic layer, data access layer. So the presentation layer is the access point for the user to the application. This could be a web application, the web pages and the front end. It could be a desktop app, an API, or it might be a mobile application or something else. So presentation layer is dedicated to that front end code. We then have the business layer logic, and this is the logic to process commands, make decisions, execute business rules, and this is the second layer. Then we have data access layer, and this communicates with the database responsible for storing and retrieving data. So the presentation layer is dependent on the business layer logic, and then that is dependent on the data access layer. So then let's have a look at an alternative, which is called the clean architecture. So we're going to do more of a comparison between N-tier and the clean architecture in the coming slides, but to give an overview of each initially, we've now got the clean architecture overview. And this is known as clean architecture, but also onion architecture or hexagonal architecture, and it's gone by different names over the years. So the business logic and the application model is placed at the very center. So when we're looking at that N-tier, the middle layer was the business logic. That depended on the data access layer, and the presentation layer depended on it. So in this scenario, instead we're putting the business logic layer at the application and the application model at the very center. Dependencies flow inwards. So the UI and infrastructure layer in this diagram depend on the application core. The UI utilizes infrastructure using abstractions defined in the application core. So when we have components of our UI layer that need to access infrastructure services, it will look at interfaces or abstractions in the application core, and then the infrastructure will implement those abstractions. So user interface won't have a direct reference on infrastructure. It will reference the application core and then use the interfaces that are in there to call the implementations and infrastructure. It doesn't reference the infrastructure layer and make direct instantiations or static calls to any implementations. It's just using those interfaces in the application core. So now to do a bit of a side-by-side comparison of N-tier. So in each of the following slides, we've got a different area, and we're going to look at the characteristic of the N-tier and the clean architecture, and then kind of look at the advantages or disadvantages of each. So we have dependency flow. So as I mentioned, in a clean architecture, those dependencies strictly flow inwards. Whereas with N-tier, the dependencies are intertwined. The advantage of the N-tier is straightforward flow for simpler projects. So again, if you're new to programming or working on a very simple project, the N-tier can be applicable. With clean architecture, clear separation ensures core logic is unaffected by the outer layers. So those application core center of the application do not depend on external factors like infrastructure and UI. So then we have the separation of concerns, and with N-tier, the separation between UI business logic and data access with those 3 separate tiers. Clean architecture, we've got very clear separation. External frameworks are at the outermost layer, so those UI and the infrastructure layers. And the advantage of an N-tier in this scenario is it follows an intuitive structure. So it's simple in the way that we've got presentation, business, and data. That is intuitive in that structure. Whereas with clean architecture, it enhances modularity and maintainability. So it's a little bit more difficult to understand the clean architecture and the way that it works and the reasons that we do that. But there's a lot of benefits, such as the clear separation of concerns and modularity and ongoing maintainability. The disadvantages, however, of the N-tier is it's not as strict and potentially mingles concerns. So it's not quite as extreme as an all-in-one application in the way that our code can be very coupled. So it's an improvement upon that, but still we could have a mingling of concerns and a mess of dependencies effectively. Then in the clean architecture, it can feel redundant in small projects without complex business logic. So clean architecture is quite difficult to implement initially, and it can seem very complex for simpler projects. So it needs to be for the right project. It's not necessarily the right approach for every project, especially simpler applications. So then we've got abstractions, and with N-tier it's possible but not fundamental, and with clean architecture it heavily uses interfaces and abstractions. So in the application core, in the center of the application in clean architecture is where we have all of the abstractions for the implementation. So that's a big part of the clean architecture. We can't have a clean architecture without using interfaces. N-tier, it's direct and means simpler implementations. The advantages of clean architecture is flexibility and easier testing, and we can swap out components. So by following the dependency inversion principle, we can, and using abstractions and interfaces instead of direct instantiations of other implementations, we can more easily swap out components without making significant changes to the code, which can then introduce bugs in unrelated features of the application. And then we have the disadvantages, which is tightly bound to specific technologies for an N-tier, and overhead of creating abstractions for everything in a clean architecture. Next, we've got testability. So with an N-tier application, it can be tested but may need more mocking setup. With clean architecture, it's easier due to the abstraction and the inward dependencies. So we've got, if we take example for the application core, the application core isn't dependent on anything. So this makes unit testing easier. We don't need to be concerned with external dependencies and mocking them. So it makes unit testing more simple. The advantage of N-tier is direct testing of integrated components, and clean architecture decoupled design facilitates unit testing. Disadvantages is with N-tier, mocking required for tightly coupled components. For clean architecture, it might need to mock more interfaces for certain tests. So then we have complexity, and I think we've kind of covered this as we've gone, but it's simpler for basic projects for N-tier, and it's a layered approach, and abstractions can appear complex. So, of course, it's key that we use abstractions, especially in the clean architecture, and it helps us meet the dependency inversion principle, but it cannot add complexity. With N-tier, the advantage is easier to grasp and implement quickly with an N-tier or clean architecture. It's better structure and maintainability in the long run for large projects. The disadvantage is it can become large and messy in large evolving projects. Clean architecture, the initial setup and understanding might be overwhelming with that structure that we need to follow, and the abstractions in the application core, and understanding the components of a clean architecture. It's easier to understand with an N-tier application. We've got presentation, business logic, and data. Simple, straightforward. We can go by the names to understand what those layers are. Whereas with clean architecture, we've got domain, the application core, domain services, UI and infrastructure. So understanding how this works is important. So finally, for our comparison between N-tier and the clean architecture, we've got ideal use cases. So for an N-tier application, it's ideal for well-defined and simpler projects. For clean architecture, it's ideal for complex projects, changing requirements, and shifting technologies. The advantage of N-tier is faster development for straightforward needs, and for clean architecture, it's scalability and adaptability for evolving needs. The downside of N-tier, harder to adapt to significant changes, and clean architecture, it's overkill for basic projects. So ultimately, there's no recommended way or recommended architecture to use. There's no one shoe fits all with the application architecture, but generally we need to consider these architectures and make a decision based on our specific needs for the application. Generally speaking, N-tier is good for simple, small projects. Clean architecture is good for more complex applications or certain applications with certain capabilities and technical complexity where it's going to provide us a lot of benefits for the ongoing application. So just going to go more now into the clean architecture. So we've done with N-tier, and we've done a comparison between N-tier, a more traditional approach, and clean architecture. But now we're going to go into the the clean architecture. I'm going to look a bit more into those layers. So application core is at the center of the application, contains the business logic. It does not depend on any other layers, and it contains those interfaces that are being implemented by implementation types in the infrastructure layer. So we've got here some examples of what we might put into the application core. We've got interfaces, of course, Pocket entities, business services, domain events, application exceptions, value objects, aggregates, and specifications. So anything that is business logic related goes in the application core project. Then we've got the UI project, and this is the entry point of the application. This is what the user interacts with, which could be an API or web app, or in this example, this is a web application, so those are the two primary examples. and it works with interfaces defined in application core at compile time. And it ideally should not know about types in the infrastructure layer, so no direct references to infrastructure, just depending on abstractions in the application core. And the examples we've got here is the pretty typical stuff we see in the ASP.NET Core web application. Controllers responsible for returning views to users, view models shaping the data of our pages, views, response caching filter, model validation filter, other filters, and ASP.NET Core identity. So then the next project is the infrastructure project. We've got the UI layer referencing the application core. In there is abstractions for infrastructure services. The infrastructure project is what then has the code for implementing those services. Examples include SMS, email, calls to external APIs, the entity framework, database context, and data access for implementation details, or the repository pattern, if that's what we're using, would be implemented in the infrastructure project. So now let's return to the key concepts at the start of this presentation, and let's see how clean architecture is intertwined with those principles and how it meets those principles. So the clean architecture, we said that high-level modules should not depend on low-level modules. And in this scenario, we've got low-level modules, UI and infrastructure, depend on high-level modules, application core, complying with the dependency inversion principle. The UI layer accesses application core abstractions and not the infrastructure concrete implementations, and the inner layer does not depend on any outer layers. Then we have domain-driven design, and the inner circle is a shared kernel for domain-driven design. Repositories define interfaces in the inner circle. Clean architecture and DDD both conform with a decoupled and modular design. So both key concepts of DDD and clean architecture. A structure that is reflective of business needs and structured to be maintainable, scalable, and decoupled. Okay, so that concludes my presentation on .NET application architectures, and in conclusion we have a number of options for the architecture of our .NET application, various traditional approaches such as all-in-one applications and monoliths, an n-tier application architecture, and the clean architecture. Thank you for watching.